what is going to be the hydrostatic pressure here. So it's going to be say dP dz. I'm going to use Z here, right? So it should be Z. So dP dz is negative rho Z, right? So this is for fluid and still, the equation. So it's not moving. So then this follows the rule, the hydrostatic equilibrium. Okay, now you have an ideal gas rho here, so it's going to be P is rho times R times T, right? R and T, R is constant here. So let me do this part. Okay, so we're going to use these two equations to come up with, the pressure as function of, Z.
So you're saying a fluid
Yeah.
acts with the same properties as an ideal gas?
Or
Or is this fluid and ideal gas?
No, fluid actually you can consider that as a gas or liquid. So
Okay.
yeah. So I mean, simply in this case, actually if you are kind of to use ideal gas law, it's most likely this is gas.
Okay.
So you can consider that as gas. Okay. Okay. Now you have two equations to come up with this here. So that what you're gonna do is you gotta integrate this guy, right? Come up with that, right? So using this ideal gas law. So this case actually rho, your density is not a constant, actually it varies with temperature, right? That's why I'm gonna write this as density as function of pressure, okay? So which is the density is P over R times T. Is that right? So however, T is function of Z now, so I can write that as P over R T now plus K C. Okay. So we got it. So now you're right. So don't confuse with rho and P. Okay, so that right here. So got it. So now, since density is not its function of Z, right? So you have to, I'm gonna write this again. dP is C must be minus this guy, right? So P over R P naught plus K C, right? So and then you have density there. So this is density times Z, right? So you gotta have G there. Okay, now what we're gonna do is just I'm gonna move this dz to the right hand side to get this guy. So basically you multiply by dz here, so it ends up being like a dp equal to minus g. G is constant, so I'm gonna take take this property out of the integral later on. So but however, g and r here, right? So you get. Okay, so integral, sorry, I have to put this first. So 1 over T naught plus Kc. Okay, so then you have the Z here, okay? Okay, then you what about the P? P is not, it must be, go to the left hand side, so it's going to be divided by here, right? So you have that. Okay, let me delete this part. Okay, now what you're going to do is just integrate, okay? Integrate 1 over P dP equal to negative G over R. This is constant, so I'm going to take the, this guy is out from integral, so which is 1 over, right? T naught plus K. C is, okay? So what you're going to do is, you will have, when you have P naught, P is P naught, okay? So your Z must be Z naught, okay? So this is the one, okay? Now when you have P is P, your Z must be Z, okay? So then you just integrate. So if you integrate the 1 over P fraction, so it's going to be logarithm, right? Log P naught from P to P naught, right? So minus G over R. So if you integrate this guy, so you have to, this is a log as well, but you have to differentiate this guy and then 1 over reciprocal of that. So which means 1 over k, okay, and the log p naught plus kz. So from z to 0, okay, from 0 to 0. Okay, if you do that, then you end up being log p over p naught, okay, which is negative g over rk. Okay, it's going to be the log, okay, p naught plus kc over p naught plus kc. Okay. Now, so you know that some algebra here. So this can be go into the power of that, right? So which is log p naught plus kc over p naught plus kc naught to the power over g over rk, right? So now then you can take the log out, right? So then you end up being, say, p over p naught equal to just this guy. However, this is negative, the power. So if you just change the positive, then this should be reciprocal, right? So then you get, okay, okay, let's say. T naught plus k c naught divided by T naught plus k c to the power of c over rk. So these are the one we put. So this answer. Okay, did you guys copy? Any questions here? I'll just remove this PowerPoint.
So did you say you raised both sides to the e and then flipped the?
Which one? Yeah, which one you're talking? So basically, these are the scale, or say it's the multiplication of the logarithm, right? So then you can actually make this as power,
Right.
right? So then I made that in here. But how is this negative power? So you can make change positive, which means this can be reciprocal now. Right? Because so for example, 1 over x to the negative power can be what? Plus x. Yeah, that is the one. Okay, now next question is, you have a cylinder with the radius r is a. Okay, this radius a, and the height is L. Okay, now you have this as y direction. Okay, sorry for my drawing. This is cylinder. Okay, so now then you have density as function of y now direction. Okay, so what you have to find is now you're computing body force. So what is the body force now? Body force. So your fluid, when it is quiescent, so it's not moving, then you have only two forces, which is body force and which is pressure, right? But in this case, you are solving just body force. Body force is just the force due to gravity.
Is that a Y or a G?
That is one,
Okay.
in this case. So, okay, this part.
Density,
This density, yes.
it's the density, those P.
Yeah, so make sure, yeah, this is density, so raw, okay. So, okay, now what is body force? What is the definition of body force? Body force is defined as density, okay, density times G vector times the volume integral, okay. So this force actually acting on this cylinder, okay, due to the gravity. So your gravity actually falls down here in the ground. So the G direction Okay, I would say it this way. You should be aware of the always reference frame. So reference frame usually I usually take is the y's above and x is on the right side. But this case actually the cylindrical coordinates, so I think x should be r and theta, but it should be y in this case, right? So I'll say that that should be y. It should be above, not in here. So something like this, okay? So then your gravity, your gravitational force is acting downwards, so which means it's negative, right? So basically, in the however, what you're gonna do is in cylindrical coordinate, you have like r, theta, and z direction. So this case, unfortunately, is y directions, right? So your g gravitational force must be now is negative g, for example, y, right? In this case, right? So now let's put that in here. So then you get your force vector is now negative g, g is constant, right? And then you have density times d times volume and the y directions. Okay, so I write this way, and then you have to put your density into the integral now. So what is your volume in cylindrical coordinate? So cylindrical coordinate and the volume, this may be useful as well than you write in your formula sheets, right? In the cylindrical coordinates, the volume must be r d theta, sorry, dr d theta dz. Okay, so this must be y. Sorry. So okay, so now you have that. Okay. So if you're gonna, plug this guy into here, for example, then negative g, y directions, okay? Now you have density, I'll split this guy. So density times, plus density times ky, plus density times ky, all right? And then the volume, r, dr, d theta, dy. Okay? So basically, you're actually integral in three, right? Three-dimensional spaces. So now you're just integral. So 2 from where to where? So basically, you're gonna. What about the r? R is going to be 0 to a, right? So 0 to a, which is radius of cylinder, and over theta. Theta is 0 to 2 pi. That's 2 pi. And then you have dy. Dy is cylindrical height is L, so 0 to L, right? 0 to L. So we're going to do just integrate. That's it. So now,
So R is RL?
what is it? R is from 0 to.
Oh, RY, never mind, okay,
Yeah.
thanks.
Okay. So now let's have like I'm gonna take just to break these guys up. Okay. This time this and this time this. Okay. Now there's negative g. From now on I'll forget about the y. This is vector, so I just use the scalar. Okay. To forget the y. So now you have 2. So 0 to 2 pi in theta is there's nothing to worry about because there's no theta in function, in the equation. So theta is just 2 pi because integrate this guy, so it's going to just be 2 pi. So then I write that as 2 pi g here. Okay. All right. And then you have 0 to a for the r and 0 to l. So now you have density times r, dr, dy. Okay. So I'll break these guys off, 2 part. And then you have 0 to L, 0A. So now ky, r, dr, dy. Make sense? Okay, now you do integral for that guy. So density, okay, let's take the density out because these are our common vector, right? So let me take these guys out here and then roll out here. Okay. Minus. Okay, now you have that. Okay, you're going to simply integrate this guy. So what is r? If you integrate the r, the r is going to be 1 over, what is it? It's going to be 1 over r squared, right? Okay, that should be. Yeah, so
Square root
I
two.
have
Or
this
square
guy,
root
so let
two.
me do this. So this going R squared over 2, right?
Yeah.
So it could be 0 to A, so which is, then you have this guy still, L dy. Okay. So this guy is, you have K, you take the K out, 0 to L, 0 to A, so which is one, this is going to be still Y R squared over 2, 0 to A. Okay, now I'll talk about something in the bracket now, okay? So this should be then A squared over 2L, right? Because there is no Y function here, so you have just first term must be A squared over 2L. Okay? Now second one, you have K times A squared over 2